All right, hey guys. So at the last week and at the beginning of the week, you were talking about arc length, which is a portion of the circumference. Okay. Then yesterday or on your previous assignment, you started talking about area of a sector of a circle. So you're talking about area of a section of a circle. So now we're talking about the area of a piece of the circle. So just like arc length was a piece of the circumference, when you're talking about area, it's going to be a piece of the entire area, okay? So your proportion is going to be very similar. You're going to do, and it doesn't matter which side you start on. So it's going to be your central angle out of 360 degrees. So depending on how big this angle is how big the area is going to be. If you have a larger angle, it's going to cover a larger amount of area. So part of the angle out of the whole angle equals the area of the sector or section out of the whole area, which is pi times the radius squared. All right, so in your previous assignment, your problems were very simple. It was pretty much plug in the pieces, cross multiply, and solve for the area of the sector or section. These problems are going to be a little bit more difficult. That's why we're going to do them together. All right, so it says the area of a sector with a radius of 14 yards is 38.28 square yards. So this is it says the area of a sector. So they're giving us the sector area, okay? They're also giving us the radius. It says calculate the approximate angle of the sector and round to the nearest tenth. So all we're doing is finding this piece of the proportion. All right, so calculate the approximate angle of the sector. So we don't know the angle, that's what we're solving for. Out of 360 degrees equals the area of the sector out of the whole sector. So the area that we have for the sector or the section, the part of the circle, is 38.28 square yards. And when you're talking about area, we did this a lot in class. If you're talking about a section, we're talking about 2 dimensions. That's where the square yards comes in, or yards to the second power, all over the whole area. And to find the whole area, you do pi times the radius squared. Well, we know pi, and they give us the radius is 14, so 14 times 14. So this is the area of the whole circle. Okay, so we have the part of the angle out of the whole angle equals the part of the area, the piece of the area out of the whole area. Okay, and this is pretty much the only thing different about this is you're solving for a different piece of the proportion, and you solve it exactly the same way. All right, so we're going to cross multiply. So 360 times 38.28. So 360 times 38.28, you get 13,780.8. 13,780.8 equals this entire number times pi. So what do we get? So 3.14 times 14 times 14 equals 615.44. I think I called this pi, my bad, times x. 615.44. I don't know what I'm doing. I'm losing my mind. Okay, times x. Okay, so then we're just going to solve for x. Divide by 615.44. Divide by 615.44. Those cancel. You're going to be left with x. Let's see. It's probably a long number, but let's see what we get. So 13,780.8 divided by 615.44. Yep, we get a long number. So it says round to the nearest tenths place. So we're going to look at the tenths place, and then we need the number behind it as well. So x is about 22.39. Okay. Tenths place is your first decimal place. We're going to look behind it. That 9 is 5 or larger, so it's going to round that 3 up. So x is about 22.4, and we got to think about what we're talking about. It says we're finding the angle 22.4 degrees. Okay, so now let's think about this really quickly. If you take these numbers and multiply them, you get the area. So let's just, you don't have to do this, but I just want you to understand, and let's see if this makes any sense. So 3.14 times 14 times 14. So your entire area, oh, I should have known that, is 615.44, okay? So 38.28 is a very small part of 615.44. So you're assuming you're going to have a very small angle. If it's a small piece of the circle, then you should have a small angle. If this was much closer to 615, then this angle should be closer to 360. Okay, so I'm sure there's more math that you could do, or I know there's more math you could do to kind of figure out if this number is actually correct, but just it's enough for us to think about, does this small angle make sense? And it does, because that is a small portion of the circle. Okay, so now let's move on to the next one, and we're only doing 2 problems together. Okay, so it says in the diagram below of circle A, you have the diameter MP. Remember, the diameter goes from one side to the other, going through the center. It's 2 radii. Okay, so it's a radius and another radius put together. Is 26. Okay, so this whole piece right here is 26. The diameter is 26. Okay, then it says the measure, remember that little m is measure, of angle GAI, so G to A to I, this little angle right here, is 30 degrees, and you're given radii. Remember, this is just a radius, multiple radius, okay? So GA is a radius and AI is a radius. So some of you may not do this to begin with, but the first thing I'm going to do is, if I have the diameter is 26, I'm going to take my diameter and I'm going to divide it by 2 to get my radius. So if your diameter, most of you can do this in your head, but if not, I'll show you the calculator. 26 divided in half, divided by 2, so your radius is 13. Okay, so that means that this piece is 13. It also means that this piece is 13. But even if you don't think these look the same, this is also 13, and this piece is also 13, because they're all radii of the same circle. It's a radius from the center out. It doesn't matter where you draw it. So those are all 13. So I could have written all the 13s out, but instead I just put congruency bars. Okay, so now let's move on to the actual question. If arc MG is congruent to IP, so they're saying that if this arc right here is congruent to this arc right here, find the area of the sector MAG in terms of pi and approximate it to the nearest hundredth. Okay, so what they're asking for out of all of this question, they're asking what this area is, the area of this sector of the circle. Okay, so now I'm sure the first question you're going to have is, why in the world are they telling us this is congruent? Okay, so remember, the arc measure is the exact same as the central angle. Okay, so if we know that these are the same, we can solve for these angles. We know these 3 angles together add up to 180. So if we have 180 and we take away the 30, we're left with 150 degrees. And if we know these 2 angles are the same, that's the big part with congruent. We know they're the same, so we can evenly split them up. Divided by 2, 150 divided by 2 is they're each 75 degrees. Okay, so we know that this angle is 75 degrees. As soon as we know the angle is 75 degrees, then we know the section of the circle and we can use our proportion. So back to our proportion, central angle out of 360 equals area of the sector out of the whole sector, or the whole area, okay? So we have the area, or my bad, the central angle is 75 degrees out of 360 degrees equals the area of the sector, that's what we're solving for, x, over the entire area, so it's going to be 3.14 times the radius squared. So we know our radius is 13 times 13. And that's it. This problem seems really complicated, but you're just solving for the area of a sector. I think most of you would have probably figured this out, but that kind of I'm sure it probably would have thrown some of you off. All right, so x times 360 is 360x. Then you're going to multiply all those numbers together. 75 times 3.14 times 13, and we get, what is that number? 39,799.5. 39,799.5. We're going to divide everything by 360. To get x is about 110 point, it says hundredths place. That means 2 decimals. So we're going to look at our 2 decimals and the number behind it. So it'd be 55.554. So 55 is the hundredths place. We look behind it. That 4 is not big enough. Remember, 0, 1, 2, 3, 4, we keep it the same. So x is about 110.55. And we're talking about area. And let's see, it doesn't have units, so it would be square units or units squared if you wanted to add area to it. Okay, so we approximated it to the nearest hundredth. Now we're going to find it in terms of pi. Okay, so all that we're going to do here is we're pretty much just going to do this again. So 75 degrees out of 360 equals x over, instead of using 3.14, we're just going to put pi there. So pi times 13 times 13. And you kind of use pi as a variable when you're doing this. Okay, so 360 times x equals 75 times 13 times 13 times pi. So 75 times 13 times 13 is 12,675 pi. Remember, you just keep the pi. It's all multiplication, but you're keeping the symbol. You're going to divide by 360. And what would be really nice if this number is divisible by 360. It's not. So a lot of the times I don't have decimals and pi. Obviously, it's okay because it's just multiplication altogether, but we're going to go ahead and round this. We're going to still use the hundredths place. All right, so we have x is about, remember, hundredths place is to 2 decimals, so we have to use the place value behind it. So 35.208 pi. But we got to round to the hundredths place, so we're going to look at 20 and then look at the 8 behind it. So 8 is bigger than 5, so that's going to round 20 up to 21. So x is about 35.21 times pi. Okay, so your answers are different. However, if you did everything correct, or if we did everything correct, this number should be equivalent to that number. And we rounded, so it may be slightly off, but it should be very close. So if you have 35.21 times pi, then we know that it's times 3.14, or estimated at. 35.21 times 3.14, and you get 110.5594. So if you rounded to the nearest hundredths, this would round this up from 110.55 to 110.56. So your answers are very much, very, very, very close. So these would be the 2 different ways, keeping it in terms of pi and rounding it to the hundredths place. All right, so It's the same exact concept as you did on the notes and practice worksheet. Obviously, those were very simple, very straightforward problems. You were doing the same thing every time. These you're going to be solving for different parts, or like a number 2, it may ask you to do something slightly different. Remember, these are the 2 problems we're doing together here, and so your next assignment is going to be the rest of the independent practice that you would normally have. I just split it up into a different assignment, so because I thought